Hello everyone, welcome to my channel. So today we are going to do Leetcode bi-weekly second question, maximum star sum of a graph. So let us first read this question, then constraint, then finally the coding part for the same. So here there is an undirected graph consisting of n nodes numbered from 0 to n minus 1. You are given 0 index integer array vals of length n, where val of id nodes the value of ith node. Okay, and then you're also given 2D integer array edges, where edges of I simply represent AI, BI denotes that there exists an undirected edge connecting nodes AI and BI. Then a star graph is a subgraph of a given graph having center node containing zero or more neighbors. In other words, it is a subset of edges of the given graph such that there exists a common node for all the edges. The image below represent the 3 and 4 with 3 and 4 neighbors of a particular graph. So the star sum is the sum of all the values of the nodes present in the star graph. So given an integer k, return maximum star sum of star graph containing at most k edges. So basically, whatever graph is being given to us, uh, in that graph, we are required to check for that star graph. And star graph is nothing but if we see that if it is undirected graph, right? So here we can see that 0 is connected to, sorry, 1 is connected to 2, right? Then this 2 is basically connected to 3 more edges, right? So how it would be that 2 is connected to 1 and then 4 and 3. So here 2 is the star graph, means this particular is the star graph with the common node as the 2. So like this only, when we create a adjacency list, we are just required to check for that, but we are just required to check turn by turn for each node, and then we are required to check that out of all those nodes which are being there, which is the maximum sum. And that is the thing which we are required to do in this particular question. So as per the constraints which are being given to us, here we can see that val.length n, then 10 raised to the power 5. These total 10 raised to the power 5 values would be given to us, means these values. Then val of I can be negative as well. And then edges length is basically minimum of this and this. Means out of them, any of could be the length of edges. And edges of I dot length means always it would be 2. That is, it is required also because there is edge between two nodes only. With just one node, there can't be any edges, right? So that's why. And then here AI, BI from 0 to n minus 1. And then AI is not equal to BI. And K is basically from 0 to n minus 1. Means basically K could be only up to the whatever length is here. So till that it could be. And the value of this val can be negative as well, as we can see here. But we are required to figure out which is maximum sum. So according to that, we will be going ahead. So now, here I had already told that the thing is that we are required to form a adjacency list, and in that adjacency list, we are required to check that what is the maximum sum which is there, and that would be our answer. So according to that, it is code this particular question. But here one more edge case which we can see here is that edges could be, and as per this constraint as well, edges could be empty as well, and value could be negative as well, right? So this thing we are required to handle. Now let us go to the coding part for the thing. So for handling that edge case, this is the portion of that code. When edge size is equal to 0, then our answer, what that answer would be, that would be simply whatever maximum value would be there in that vals array, So that would be our answer, and that we will be returning at that moment only. So that's the thing. And this is how we are handling the edge case. Now comes the main part of our um, question. So here we are first making the adjacency list, right? And this is how we are making our adjacency list because it is undirected graph. So that's why this is how we will be making our adjacency list. And this is that portion when we are connecting with this, and 2 is connected with 1, and 3 connected with 1. So this is what we are doing here. Now comes the next part, is how we are required to figure out with the maximum sum. So we're checking for the maximum sum. What we are doing is we are here having this particular. So first we are sorting in descending order, so that because there is constraint that we can have at most k edges, k k nodes only, right? So because of that thing only we are sorting in at descending order. So whatever would be topmost k nodes, so we can get the sum of those. So that's why we are sorting here, and then we can go up till that k or whatever is the length of that particular part of that adjacency list. So whatever would be minimum, so we will be going till that, and then checking for ignoring the negative values, we are doing this portion and then directly adding up to our answer. And then here we are then checking whatever value is there, then adding up that and then checking for the maximum. Then at the end, returning our maximum. So this was all required for doing this particular question. Now comes the part about time complexity and the space complexity. So for the for the time complexity, here we can check that this is order of n, right? And then this is also order of n. Then this is order of n again, but this is order of log n, right? So because of this, we can see, and then comes the part, and this one is uh, order of k, whatever minimum would be there. So that's the thing. So as per this particular, we can see the time complexity for the same would be order of n log n. We can here n is basically, here you can see that k can be up to n, but k is less than n, and k could be a negligible part as well. But still, let us consider only because it could go up to n as well, right? So that's why time complexity becomes k into n into log n, and the space complexity here is just for this particular vector which is there, means this one. So that's why the space complexity for the same is order of n. So yeah, this was all for this particular question. If you have any doubt, you could comment that down. And yeah, this was all. And one more informational thing. As you're already doing these Leetcode bi-weekly and weekly challenges, you could also check in the description below for Newton School coding contest. And that coding contest, if you are the top performers, then you will be getting some exciting prizes. For the same also, you can check in the description only. In that link, every information is there. So yeah, you can practice there as well. So this was all for this particular video. So yeah, thank you.